All right, day 8, interpreting graphs of linear functions. Here we look at the axis and the title, and we can get a sense of what's going on. This looks like the height of a plane. And as you can tell by the graph, as time goes on, height is decreasing. So you can just jot this down here on the side. That's pretty much the best part about graphs. You can get a really strong understanding at a quick glance. It's pretty much the whole point of a graph. So as t increases, height is decreasing. We can expand that further, and we can even talk about at what rate is it decreasing. And it's decreasing at a constant rate. And when I say constant rate of decrease, what I'm talking about really is this word right here, linear. Linear graphs have constant rate of change. And we'll find that constant rate of change shortly. So answering the first bullet, where does the graph intersect the vertical axis, and what does this point represent? So we're going to scan the vertical axis and scope out this point right here. That point right at the top of the graph, it has a value of 0, 1000. 0, 1000. So what does that tell us? At 0 time, the height is 1000 meters. So what does this point represent? You know, it's probably flying at 1000 meters before the plane starts its descent. So we call this an initial value. I want you to think about the word initial in the sense like it's the beginning value. It's the start point, the initial starting place. That's because the time is 0. Does that make sense? Now, what do I mean by the value? Well, that would be 1000 meters. The initial value is 1000. Hopefully that kind of makes sense. We have a special name for that spot. We call this the y-intercept. As the point where the graph intersects the vertical axis, we call it the y-intercept, otherwise known as the initial value. All right, where does the second bullet here, where does the graph intersect the horizontal axis, and what does this point represent? Well, if you scan down over here, what's the ordered pair here? At 10 minutes, the height is 0. So in this context, what does this point represent? I would say it's the final value. Why is it the final? Like, I'm assuming that the height being 0 would be like the reference point of the ground. Are you going to be traveling under the ground or under the water or whatever this is? You land the plane on the ground. Do you want to go underneath the ground? No, that's as low as it gets, so that's the final value. So just like above, we have a special name for this one. This one's called the x-intercept. And it has a value of 10, 0. All right, now for the rate of change. Good, he's got it. For the rate of change, just use the delta y over the delta x for the entire trip. So for the entire trip, I'll draw a big line, and I'll color it in green. That right there is the delta y, and this right here is the delta x. So how much did you drop by? How much did you drop by? 1,000. So we actually have to put minus 1,000. Alright guys, welcome back after that fire alarm. That was awesome. So as we collect our thoughts, come back to the lesson please. Make sure when you are calculating the rate of change that you include the units. So we lost 1,000 meters, and that took us 10 minutes. So all you have to do is punch that ratio into your calculator. Negative 1,000 divided by 10. I can't believe I used a calculator for that. And we got minus 100 meters per minute. So what I want you to try to do is try to find the steps. Try to find the 100 meters lost every minute, and you can see it goes like this. We go down 100 over 1. Down 100 over 1. Down 100 over 1. And that continues on forever until you run out of height. Okay? You guys feeling okay about those notes? All right. So I'm just going to write a few notes for the x-intercept and the y-intercept at the bottom of the page here. So for the x-intercept, just draw a grid. Just sketch a quick grid. And the x-intercept, of course, will lie somewhere. It could lie anywhere on the x-axis. So for example, that could be an x-intercept. It could be anywhere along the x-axis. And it will have an x value, and of course the y value will be 0. Alright, so for an x-intercept, especially if you have to solve for an x-intercept algebraically, you need to set the y equal to 0 and solve for x. Now graphically, you just have to find the point on the grid where the y is 0. But algebraically, you need to be able to set the y value to 0 and then solve for x. And similarly, we will sketch a similar idea for the y-intercept. Now the y-intercept, of course, will be anywhere along the y-axis. So it will have an x value of 0 and some y value. That's what the y-intercept looks like. So for the y-intercept, if you were to solve for the y-intercept, you would have to set the x equal to 0 and then solve for that particular y. And for sure that will be something you guys have to be able to take care of in this course. And the bottom little information box says that all graphs of lines are functions, except for vertical lines. As long as it's not a vertical line, it will be a function. And so we call them linear functions. And in fact, the whole next unit, the whole next chapter is on linear functions. So this is the next unit. This is going to be chapter 6 after this week is done. Alright, so this is a worked out example for you guys. Everything's done for this example. Let's just quickly identify the key ideas. Right here, x-intercept is 4, and you can identify it on the graph right here. So use the units and the axis to help you. That means at 4 hours, the temperature is 0. So I really prefer that you guys use the units. So at 4 hours, it's 0 degrees Celsius. It helps you to understand the context of the situation. Now for the vertical intercept being -5, you can see that spot on the graph right here. That is when the time is 0, the temperature is -5 degrees Celsius. And you can see the key word here, the initial temperature, the initial value. Now the domain and range is going to continue to show up in your math courses, whether it's math 10, 11, or 12. You will always have to solve for domain and range. Of course, domain is x and range is y. That is why you can see the domain is using little t. That's for time, little t. And the range is using capital T for the y-axis. And you can see, even look at the top here, the temperature is a function of the time. Temperature is a function of time. So what that tells you is that the temperature depends on what time it is. Temperature is a function of time. So to answer the domain and range, I'll use my pointer. Look at the domain for the time. Why is it from 0 to 12? Well, that's how long this experiment was running for. Starts at 0 and ends at 12. So t, the time, is squished in the middle between 0 and 12. Look at the way the arrows are pointed. Which way do the arrows point? To the left. Now for the range, this is now going to be your vertical possibilities. The lowest temperature to the highest temperature, this is the range. From -5 to +10, that's the range. And then they calculate the rate of change. They're saying it's 5 degrees Celsius for every 4 hours. How could we find this 5 degrees Celsius for every 4 hours? So make a triangle. Okay, make a triangle. Identify 2 points. This point here and this point here. Make a triangle. In 4 hours, the temperature will rise by 5 degrees Celsius. So it went up 5 degrees Celsius in 4 hours. You make a ratio with the y value on top of the x value. Remember, it's delta y on top of delta x. 5 degrees Celsius in 4 hours. Okay, at the bottom of the page it says the rate of change is positive because the temperature is increasing over time. And this example over here on the next page, it's the exact same stuff, so I'm not going to run through it again. But you can see here at the bottom, the rate of change is negative because the temperature is decreasing over time. So I'll just do the slope for you guys for this page. Find 2 perfect points. And then make a triangle, a right-angled triangle. I can see here in 5 hours, because I've gone from 0 to 5, how much did it drop by? -10 degrees Celsius. So then you put the delta y on top of the delta x, negative 10 degrees Celsius in 5 hours. That will reduce, because negative 10 divided by 5 is just 2. So negative 2 degrees Celsius per hour. Negative 2 degrees Celsius per hour. So we got 4 examples to cover. This is the first one. This will be almost identical to what your quiz looks like tomorrow. Tomorrow you'll have a quiz, a practice test, and then the exam is on Friday. So this graph, you can see you have volume versus distance. So right there, there's an equation that says that volume is a function of the distance. So depending on how much you drive, how far you go, how much gas do you have in your vehicle. So obviously the more you drive, the less gas you're gonna have. All right. So x-intercept, where is it? 200, comma, 0. What does that mean? It takes what? 200 kilometers of driving to use all the gas. Do you agree with that? Okay, where's the y-intercept? 0, 8 or 8, 0? 0, 8. What does that tell you? You have 8 liters of gas to start with. Before you do any driving, how much gas do you get? You get 8 liters. That's your initial value. Well, it's a scooter, not a truck. Now, domain and range. Excuse me. For the domain, I'll use the lowercase d for distance. And because this is a bounded situation, like there's no infinities here, I know there's a left endpoint and a right endpoint. These ones are actually quite nice to do. Point the arrows to the left, put the left endpoint on the left, and the right endpoint on the right. And then if you want to be really nice, you can throw these little squiggly brackets on there. That's the domain. So similarly, could you take care of the range? Well, what letter should I use? Capital V, because I'm trying to follow along with the function notation that they've given me up at the top there. V is a function of D. So V, what's the biggest value for V? And the lowest? 0. And then you can put those little squiggly brackets on there. That is the question tomorrow on the quiz. It'll be different numbers, of course. So you can totally prepare for this, you guys. Okay, next one. Sketch a graph of the linear function negative 2x plus 7. On the quiz today, how did we sketch our graph? What did we do? We made a table. And then you had all these dots lined up. And then what'd you do? You connected with maybe your ID card or something. How many points do you need to make a line? Is it enough to just have 1 point? Is it enough to have 2 points? Yeah, all you need is 2 points and a straight edge. So it's nice if you want to sketch a graph, if you don't want to build a table, just use, and this is only true for linear functions, just use the x-intercept and the y-intercept. So the x-intercept. Which value is 0 for the x-intercept? Where does the x-intercept live? It lives on which axis? The x-axis. So what's 0 on the x-axis? Which value? The x or the y? Yeah, the y. So for the x-intercept, set y equal to 0. So which one of those symbols is the y in that equation? It's not even there. It's this one. This is another way of writing the coordinate y, because that's the function applied to x. So I'll say, okay, y is equal to negative 2x plus 7. I'm going to say that y is 0. So 0 equals negative 2x plus 7. And now I solve for the x-axis, or the x-intercept. How to solve that equation? I have to isolate the variable. So what do I got to do first in this two-step equation? Do I move the 7 or do I move the 2? Which one? Does it matter? It's got to move one of them. You want to move the 7? But then I got to divide by a negative. Why don't I just move the 2x? You want to just do that? Okay, add 2x. Add 2x. Then you get 2x is equal to 7. Now how to solve for x? Divide by 2. And 7 halves is 3.5. So that's the point. 1, 2, 3, 4, and so on. 3.5 right in the middle. Okay, so that's the harder one. The easier one is the y-intercept. For the y-intercept, it's going to be somewhere along this axis. So what is 0 on this axis? The x. So all I got to do is say, okay, set x equal to 0. Now when I go to use that equation, obviously I set the x to 0. What's negative 2 times 0? 0. 0 plus 7? 7. You will come to see, if you do enough of these homework questions, that the y-intercept is always the constant, because all the x's will be gone. All of the x's will become 0, and the y-intercept is the constant. So you can now go and find 7 on your grid. 1, 2, 3, 4, 5, 6, 7. So there's 7. Now, what do you need to draw a line? Just a straight edge. Use your ID card or a ruler. And we connect. I missed. And what do we do in the lesson today? Did we just leave it like that, or did we put nice little arrows on it? And again, why do we put the arrows on it? Not to show it's continuous, to show that x could be any number, and therefore y could be any number. Because it's an equation. You could put any value of x in there, times it by negative 2, and add by 7, which means it could go on forever. So one last thing before we move on from this question is the y equals mx plus b format. In our question, what is the m value? -2. I wonder if you could find that on your grid. Over 1, down 2. Over 1, down 2. So if the slope is -2, that means you're going to lose -2 for every 1. You lose -2 for every 1 over. -2 for every 1 over. And the b value, of course, is the... What's the b value here? This is 7. And that's, of course, your y-intercept. So for this format, slope and y-intercept. All right, moving on. Is it okay if I slide? All right. All right, so which graph has a rate of change of 1/2 and a vertical intercept of 6? So the first graph has a vertical intercept of 6, and the second graph has a vertical intercept of 6. So is that going to help us? So which one of those has a rate of change of 1/2? So this one goes over 2 and up 1. So rise over run would be 1/2. So it looks like this one. So why not A? This one's over 2, but it's down 1. So the rise over run for the second graph, or for the first graph, is -1 over 2. Okay, so this is not the one. This is the one we want. Any issues there? So for slope, there is a fancy calculation for slope that we're going to take care of in the next chapter. So when you're doing slope in this chapter, it's pretty straightforward. You just look at the triangle, make a right triangle, find the rise and the run, and make the ratio. All right, the next one is about a school yearbook. So let's take a look at this relationship. The more yearbooks that you produce, the more it's going to cost. Is it connected? Why isn't it connected? Can you make half a yearbook? Nobody's going to want that. So yearbooks come in units of 1. You can't have half a fractional yearbook. So that's good. It's discrete. Let's go to answer the question though. The budget for publishing costs is 4,200. Well, what is the maximum number of books that can be printed? So we can use the graph to get an estimate. What are those scales going up by on the y? Each one is going up by 500. So this one here is 4,500. And they said they have how much money? 4,200? So it's going to be somewhere in between here. So I'm just going to interpret the graph and I can get an estimate. So I can estimate about 175 yearbooks. Okay, but I can do better. I can generate an equation What is the y-intercept? What's the y-intercept? Help me out. I'm just going to remove this red dot so you can see it. What's the y-intercept? Loud and proud, guys. What is it? 500. So what can I replace in the equation with 500? What can I replace? The m or the b? The b, good. So how do I replace the m? What goes in the m? The m is the slope. So could I find the slope? Let's zoom in. What's the rate of change? As you go up 50 in the x, you go up how many books? Or pardon me, how many dollars? How much? 1,000. So if you go up 50 books, you have to spend an extra $1,000. So $1,000 for 50 books. You can get the rate of change. 1,000 divided by 50 is $20 per book. So now I can replace m with 20. Now I have an equation, and now I can be a little bit more accurate than this estimate. So where do I put the $4,200 in the equation? Well, $4,200, look at the unit, it's a y value. So that's a y value. I can do a substitution right here. 4,200 is equal to 20x plus 500. Now how to solve for x. Subtract 500 to isolate the term x. 4,200 take away 500, I'm looking at 3,700. And now last step, just got to divide by the 20. And I'll see how good my estimate was. 185. So I was close. So the assignment is at the bottom of the page. You have the east bell is about to ring here. That was like perfect timing. Oh, it looks like they turned it off, maybe. So anyways, the homework's there. Good luck. You're going to stick around in my class until block 4.